Good afternoon, ladies and gentlemen. So my research is on the importance of user's perspective in knowledge extraction for semantic web. I did this research with Dr. GDSP Wimalaratne, who is a senior lecturer at University of Colombo School of Computing. So without taking much time, I will straight away go into the details or the background of the research. As we all know, the World Wide Web is overloaded with information, and it is growing so fast. And the exponential growth of the digital documents in the World Wide Web has given rise to enormous amount of problems. So it is really difficult to extract knowledge or get or retrieve documents in the web. So the solution for this problem is to replace the traditional web with semantic web. The backbone or the core of semantic web is what we call ontology. So all semantic web applications are developed on top of an ontology. The vision of semantic web is to have data on web linked in such a way that it is really machine understandable. So this is the difference really between semantic web and the traditional web. In semantic web, the documents are really machine understandable, but in traditional web, they are only human understandable. You and me can really understand, but not the machines. That's the problem. So I told you that all semantic web applications are built on top of an ontology. So ontology is a specification, formal description of set of concepts and relationships. Normally these ontologies are manually constructed, but manual construction of ontology is a very time consuming, tedious, costly task. For example, if you want to develop an ontology, let's say for communicable diseases, for that you need expertise knowledge, you need time, you need cost. Therefore, manual nature of ontology development hinders the fast growth of semantic web. Ladies and gentlemen, this is my research problem. So I am trying to address this point, and my aim is to extract knowledge from large number of web documents in order to develop ontologies in a semi-automatic way. But the problem is, if I analyze the current research attempts, they only focus on the web content when they are constructing ontologies. But actually, if you take web resources, there are three main parts. The first one is web content, then comes the structure, then comes the web usage patterns. So what my argument is that we need to take into account all these perspectives. In my research attempt, I am trying to combine two aspects, that is the web content and the web usage. So my argument is that there are two sets of users. That is, there is the author who designs the web, and there is the user. So since the author designs the web, the conceptual relationships that are seen by the web author is normally reflected in the web content. But the web users could view the same set of conceptual relationships in another way. So my argument is that we need to take into account both these perspectives if we are going to develop an ontology, and it will improve the precision of the ontology. So this is how I am going to do it. I am taking into account the web author's perspective using web content mining, and the web user's perspective using web usage mining. Going into my methodology, as you can see, there are two clear parts. I am extracting conceptual relationships using web content mining. Then I am extracting conceptual relationships using web usage mining for the ontology. So first let me move to the first part. And here also the most important or critical components are the concept extraction and the conceptual relationship extraction. So let's see how I have done it. How I have extracted concepts from web documents. For that, I am using weighted frequency. So I am taking into account the frequency of a term, and more importantly, the position of it in the document. When I say the position of a term, I mean the HTML markers that are wrapped in this particular term. So based on that, I am calculating the weighted frequency, and by using externally specified threshold value, I am trying to extract the concepts. For that, I need sentence structure analysis information also. So through part of speech tagging, as you can see now in the slide, each term is tagged with its grammatical category. So it results us in well-formed terms, and it is really important if you are going to talk about concepts. So this is how concepts are being extracted. So after we identify the concepts, next challenge is to identify how they are related. So this is my solution. I view each and every web page using a logical tree structure. So each and every web page is mapped, as shown in the slide, is mapped to a logical tree structure. So this logical tree structure is developed based on the HTML markers. And I traverse along this tree. I calculate 3 measures: support, confidence, and the strength. Support and confidence, of course, I think all of you know. They are very famous measures in data mining. But the relationship strength is a new measure which I have introduced, which measures the strength of particular 2 concepts based on the HTML markers where they reside. So for example, if the 2 concepts are occurring in the title tag or meta tag, so on and so forth, I have identified several relationship strength affecting factors and weights are assigned according to that. So finally, what we have is, for a given conceptual relationship, we have 3 measures. That is the support, confidence, and the strength. So I used the supervised neural networking approach to derive the weights that should be assigned for these inputs so that I can finally obtain the relationship value. So then now I have for each and every conceptual relationship a relationship value. So by using externally specified threshold values, again I am extracting the important conceptual relationships. With that, my first phase is over. So let's move on to the second phase, where I am going to extract conceptual relationships by looking at the user navigation patterns. For that, ladies and gentlemen, all information about the user is stored in the access logs. So access logs, first of all, need to be cleaned. It's raw data, we have to clean it. So that's simply pre-processing, cleaning it. Then we need to identify the user sessions from the access logs. Then what I do is I cluster these user sessions together so that I result in a group of, I get clusters where I have similar user sessions clustered together. And then for that I used k-means clustering algorithm. K-means is a very known unsupervised learning algorithm. So I used k-means clustering algorithms to cluster these user sessions. How I did that was, I mapped each and every user session to a multidimensional vector space. If you can see, I mapped each and every user session to a multidimensional vector space, and I used k-means clustering algorithm to cluster these user sessions. So for each cluster, I applied the a priori algorithm, and then I identify the page sets. Page sets are pages which are frequently accessed together throughout the same user session. So if several pages are frequently accessed together throughout the same user session, that means there is some kind of relationship according to the user point of view. So I'm going to take that information now. So keeping that in mind, let's move on to the last stage. In the last stage, I'm trying to identify the suggestions. So for that, I identify the negative border. What you mean by negative border is, I lowered the relationship value which was used in the web content mining. Then I cross-checked whether those concepts are appeared in the page sets that I just found out. If so, I present them as suggestions to the ontology developer. So I really developed a prototype. Then when I gave the input, this is finally the OWL file that was generated. OWL is web ontology language, where it's really machine understandable. So going to the evaluation, I used the BBC wildlife ontology as the gold standard, and I used the precision and recall, very famous 2 measures used in information retrieval. So I calculate the precision and recall for conceptual relationships using the BBC wildlife ontology. With that, I come to the end of my presentation. So thank you very much for listening.
Thank you very much.